Alright, so my name is Holly Bernesser, and I am in the math group. I did my project on divergent thinking in math. I believe the whole topic was math as divergent thinking versus convergent thinking. I focused mostly on divergent thinking. So I did a blog for my solution. To be honest, I couldn't get my computer to run the websites. They didn't want to not freeze on me. So over here on the left, as you saw, was archive. So your screen will look like this. Just drag it down and you'll have all the posts. There will be one more with this video on there for you. So you'll see a number 9 probably with video or me talking or something like that. So click on number 1 and it'll take you to Introduction to Divergent Thinking. So first you need to know what it is. Well, kind of as you can guess from what divergent means, you're going to diverge off of an idea. So it's an idea generation technique like brainstorming, where an idea is followed in several directions to lead to one or more new ideas. And that still leads to even more ideas, which is opposite of convergent thinking, which aims to solve a specific problem. So that's your basic definition of divergent thinking. It's worded far better right here in this little paragraph. But because it also mentioned the converse idea of convergent thinking, I wanted to define that as well. So down here we have the definition of convergent thinking, which generally means the ability to give the correct answer to standard questions, but do not require significant creativity. And that's pretty much like your standard multiple choice tests in school where you have A, B, C, and D and you had to memorize what the answer was. I'm sure we all remember those tests. So that is your basic definition of convergent thinking. And then, because I'm not always the best at writing out these types of definitions in words, there is a little video right here which you can click on and we'll play for you. And it's a teacher from Harvard who's going to talk about
divergent and convergent thinking is the...
And I just realized she talked over me. I'm sorry. So hopefully her little introduction, it's only about 3 minutes, I believe, about 3.5 minutes long, helps as well. And then you can see number 2 down here, but because it may or may not show up on your screen, if you pop back up to the top and go to archive over here, go back down, hop to 2, you have application to math, since that is my concentration area. So applying this creative approach to math seems complicated. Math typically has one answer, but that may not always be true depending on how you ask a question. So in this post, we're going to talk about applying it to math. So most people would say that math has one answer. It's 7. No, I'm kidding. Okay, it's because we only ask for one answer. If I ask you, well, what's 2 plus 2? You're gonna tell me 4, unless you're 5 and you tell me fish, which isn't always wrong. I mean, you could put the 2's together and get a fish. Why not? But why do I say that 2 plus 2 is not 4? Well, would you believe me if I said the answer was 16? No. So here's why. If we believe that 2 is actually 2, then yes, 2 plus 2 is 4. But what if 2 was actually 8? If in this world 2 equaled 8, in that case 2 plus 2 does equal 16. It's just a small little example of a divergent thinking exercise to get you thinking a little differently. How could you make this equal something else? Well, what if 2 wasn't actually 2? It could be half a fish plus another half a fish, and then you get a fish. So there's always this misconception that it's the same thing as creativity with divergent thinking, and that's not actually true. It's an essential capacity for creativity. It's a step in helping you be creative. It's the ability to see multiple solutions or to interpret questions in a multitude of ways. So divergent thinking is a part of it, but it's not the whole of creative thinking. So following the first part of the post, we need to change how to ask questions, especially in math. So how would we do that? You want to give students the ability to think differently and have multiple ways of solving a problem. not restricting them to only one method. To do this, especially in a course like math, you want to use open-ended questions. A question like this on a really small scale that any one of us should be able to answer would be, what plus what equals 10? 5 plus 5 equals 10. 1 plus 9. There are an infinite number of responses, and they're all correct. This type of question gets you to think about the problem. What does it mean to add? Is it somehow connected to subtraction? Do the two numbers have to be whole numbers? Can there be decimals? As a teacher, you really want your students to ask questions like these when working on a problem. In math, it can be hard to get students to engage with the work, but an open-ended question helps them to be invested in the problem and the solution. There's also a really great study on using this type of teaching for open-ended questions in a middle grades math classroom. It was done in Korea, but it's still math in the middle grades. So if you want to read through it, there's some cool little pictures of some questions that were asked. This little blue link here will take you to that. And then we can again hop up here to archive and go to 3, called Curiosity and Motivation. And as you might be able to guess, a lot of these posts are based on videos or articles. This one again comes off of this TED Talk by a high schooler, actually. He is an 11th grader in the video. And he talks about curiosity and motivation in a quote by Thomas Friedman that says, "Curiosity combined with the motivation to learn is much more important than pure intelligence." When someone is interested and curious and motivated to learn, they do so. He talked about wanting to design an app, and he was a 9th grader, and he did design an app. He was so interested in it and so intrigued that he went out of his way to go and learn about that. So he did. The same applies to things like math. While I do have a degree in math, it's because I enjoyed it. I wasn't always the best at it, but it's because I liked it. I went out of my way to learn about it. I have textbooks of no importance, but they were cool and I read them. I was interested and intrigued, so I learned and got better at it. So you want your students to be interested in what they're learning. If someone is not interested in it, they're probably not going to give it much thought. This video talks a little bit more about that. And he also mentions an independent project for a year that students could do if we were to integrate more divergent thinking into a school system or into a classroom. He also talks about testing, which is really useful. Like, how would you test divergent thinking? And it's kind of like the previous post, going into open-ended question. So do give the video a watch or scroll through it a little and see what you get. We'll hop to number 4, seeing as I realize I'm at 8 minutes. A good question is this already out there? Is that divergent thinking included already? The answer is yes. There are many schools that use this. A well-known one is in England, and it's Oxford. And yes, the actual Oxford, not the small one, the big one. When you apply for Oxford, you take a one-word exam. Like in this little video down here that you can see, she talks about it as well. Words like integrity or water, and they want you to write about it. And you write about your life and your experiences and just whatever comes into your head for 3 hours. It's another divergent thinking method to open up your creativity and see what you can do with it. Can you follow this path and write out a really interesting paper, or are you stuck at a wall? We are naturally creative people. The caveman built a wheel with creativity and maybe some trees. So over here to number 5 is, why isn't this happening as much as it should? My belief, and the belief of many others that I have watched on TED Talks and read in articles, is a school system. Our school system was created in a time of the Industrial Revolution and for a specific class of people to end up with a specific type of education. In this day and age, that is not the same. Everyone goes to school, no matter your class standing or where you come from. They all go to school. So that is something that would have to change for this to be more prevalent. There were studies done that show everybody is capable of divergent thinking. A group of about 1,500 students were, from the ages of 3 to 5, were tested on divergent thinking. 98% were considered geniuses. Again, if you read through this a little bit more, because I'm running out of time, I don't want this to go for 20 minutes. It'll explain more. This first little animated video is really interesting. If you want to hear more about the divergent thinking part, it's about 8 minutes in. This is by the same guy, Sir Ken Robinson. He gives some really good information on how schools are now and how they could possibly be, as well as other schools out there that have incorporated creative thinking or divergent thinking. There is a good example of this type of school called Templestowe College. It's in Australia. They do an independent learning plan where students get to create their own schedules and pick their own subjects. For their first 12 months, they do prove their basic English and math, which I believe he calls literacy and numeracy, Australian terms. But it's a school where divergent thinking is routinely integrated, whether they realize it or not. They have given the students to be able to be creative and to think outside of the box without saying, no, that's wrong, there's only one answer. It's basically what I would picture as the future of education, that this is what it should be, a school where all the students are engaged and enjoy learning. I'm going to quickly hop over to 7, and it's called Try It Yourself. Yes, it is what it sounds like. There come the videos. They're being really slow. Okay, so this post has a couple of videos where you can try out divergent thinking yourself. So it is important to apply it to math, but it is also important to apply it outside of that. So a lot of it shows that divergent thinking can definitely be applied to math. But more importantly, not just math, but to the entire way of learning. So some of these videos will see, can you think divergently? Or here's a better explanation of divergent thinking. Some are really short, like this little brick one down here. It's about 1.5 minutes long. And it's just how many uses can you think of for a brick. Also, like, how many uses can you think of for a paperclip? Most people can do about 10 to 15, but the really good ones can do 200. So just give a couple of them a shot. We've got some interesting ones, like this little dot one you may have seen before. This one down here, just a forewarning, has a very strange narration going on, but some really cool activities just to give a shot. Maybe you'll find it interesting as a teacher. And then post number 8 are all of my references. I do apologize, I didn't realize it posted them this weirdly. That's very strange. I'm going to try and fix that. But here is all of the references, mostly from my paper, but that I used again in here. I'm not going to relist all the videos because they're already in here. Just the ones that were already in my references. So I do hope you enjoyed. There's a really cool futuristic picture. Wouldn't school be awesome if it looked like that? So thank you, and hope you liked it.